Welcome to the Deep Dive. You know the drill. Every day, your feed just bombards you with headlines. Who won the game? What big global event just happened? Which new tech platform dropped? But underneath all that, there's this kind of invisible operating system. It's grading, ranking, selecting the world for you. Today, we're diving past the surface news. We're going straight into the algorithms that shaped how we consumed everything, from, say, a game-winning NFL field goal to the fallout from a major logistics strike.
Exactly. And our source material today connects these really visible breaking events. Could be news of a prominent figure passing away, or maybe a crucial commercial disruption. It connects them with specific algorithmic decisions. We're really looking at the fundamental AI angle, how it didn't just passively report the news, it actively determined its speed, how it was synthesized, and, well, ultimately, your individual point of view.
Right. So our mission, for you listening, is to help you quickly get informed, not just on what happened, but on how this whole knowledge economy decides what's important. We want you to kind of see the machinery behind the content. Okay, let's unpack this, maybe starting on the field, where AI seems to be changing the scorekeeping itself.
Yeah, the world of sports gives us a really clear view of this shift because AI has moved way beyond just, simple stat sheets. It's actively influencing player perception now and even market behavior.
Okay, let's kick off with the NFL then. We saw the Seattle Seahawks beat the Arizona Cardinals 23-20, last-second field goal. The score itself, pretty straightforward.
Yeah.
But the analysis after the game, that's different now, right?
Oh, completely. The game isn't just graded by human coaches anymore. Now you've got systems blending advanced computer vision tracking, measuring really specific things like a quarterback's time to fire or throw velocity, and mixing that with sophisticated performance metrics. The key one our sources point to is expected points added, EPA. That alongside these Bayesian injury risk models.
Okay, hang on. For listeners who maybe don't follow advanced metrics every single day, can you just quickly ground us? What does EPA actually measure in simple terms?
Sure. EPA, it's essentially a dynamic score for how valuable a single play was. It calculates how much positive or, negative impact that specific play had on the team's chances of scoring next. It moves past just simple yardage. It tries to measure the real impact on field position and momentum. But here's the critical insight from the sources, especially regarding a mobile QB like Kyler Murray. These AI ranking systems, they're not neutral. They're not just curating content. They've been observed to deliberately overserve highlight clips, specifically rushing highlights. And they serve them to viewers who the model thinks prefer mobile quarterbacks.
Wait, overserve. You mean the system is actually prioritizing content based on what it thinks I want to see, even if that specific clip wasn't, statistically the most important moment of the game?
Precisely. It's feeding into a confirmation bias based on your viewing history. And the sources point out this specific algorithmic nudge, this push towards certain content. It has real-world financial implications. Specifically, it influences prop bet pricing in real time. The algorithm is subtly shaping how the market perceives a player's style, financially speaking.
Wow. Okay, so if I'm betting on, say, Kyler Murray's rushing yards, the system is actively reinforcing a positive view of his scrambling through selective highlights, which then justifies or at least influences the betting price. That feels like a really significant kind of self-reinforcing feedback loop. Okay, let's move to global football. Real Oviedo versus Barcelona. Barcelona won 3-1, but they were trailing at halftime. What invisible data points matter here?
Yeah, here we shift from those big financial models to really micro-analysis, player movement. Clubs now grade these matches using things like pose estimation and expected threat models. These tools quantify actions that are literally invisible in standard stat sheets. We're talking critical off-ball actions. Things like, well, the sources call them lane creation and micro-press triggers.
Lane creation, micro-press triggers. Those sound super specialized. How is an AI system assigning value to something like a micro-press trigger? What even is that?
Well, think of it like this. It's that instant a player, maybe they're even off-screen, shifts their body posture just slightly or takes one specific step that signals to teammates, go now, press now, the defense is vulnerable. The AI assigns value to that tiny fractional movement. It makes it clear that maybe the player who didn't even touch the ball was actually the key driver of that momentum shift or the scoring chance that came next.
So it's quantifying player intelligence, timing, stuff humans might miss. Okay, let's jump across the world. Cricket. Pakistan beat Bangladesh by 11 runs. What's the AI angle there?
Here, the focus is on ball-by-ball win probability engines. These systems are fusing historical data like line and length of deliveries with these complex numerical representations of a batter's tendencies. They call them batter embeddings. And what's more, fielding heat maps, derived from computer vision and sensors, they forecast likely scoring zones, maybe an over ahead. This guides both the graphics you see on the broadcast, the telestration, and also the captain's decisions on the field.
Right. And finally, a quick look at MLB roster optimization. Blue Jays-Yankees games mentioned in the sources.
Yeah, two really distinct uses here, operationally speaking. First, strategy. Lineup optimizers simulate platoon splits against the probable bullpen pitchers a team might use late in the game, trying to get the best possible matchups. Second, injury management. These injury trajectory models. They're now estimating rehab timelines for players, like the example of Jose Barrios' elbow. This guides those really crucial roster moves, helping teams maximize flexibility weeks in advance.
That is, wow, a staggering amount of algorithmic influence just in sports. Perception, strategy, finance. Okay, let's pivot now. Let's talk about the architecture of attention itself. If AI can grade a player's worth, how does it decide which news story is worthy of your attention? Here's where it gets really interesting. Seeing the machinery that determines public memory, public discourse.
Right. And this segment really deals with how quickly sometimes deeply niche content can be sort of repurposed for mass audiences. And often it leverages raw emotion to get velocity, get speed.
Okay, so we saw the passing of the Christian author and seminary leader, Voddie Baucham Jr. Now, for someone whose main content was pretty specialized theology, his death moved very quickly into mainstream news feeds, generated widespread tributes.
The recommendation systems really drove that. His content was rapidly relabeled, shifted from, niche theology into general news. Our sources detail the mechanism. It's a combination of topic model analysis plus this powerful emotional thing called sentiment drift.
Sentiment drift. Tell us more about that. How does this system even figure out that a shift in topic, or maybe sentiment, is happening?
Well, initially his content was clustered under very specific theological labels, right? But as all these memorial clips started flooding the platforms, the system detected this massive generalized sentiment spike. Grief, tributes, remembrance. This emotional wave transcended the original topic labels. So the system interprets this big emotional shift as a major news event that allows the content to kind of drift out of its niche subscriber pool and into almost anyone's feed. Basically, any user who responds positively to high sentiment memorial posts, it maximizes reach based on that collective emotional momentum.
So the algorithm it's almost weaponizing a shared emotional response to boost its own content velocity. That makes sense for spreading news quickly, I guess. But what about making sure we can find specific content, especially across languages? Let's look at that Real Oviedo versus Barcelona match again, but this time from, say, a Canadian search perspective. Fans might use different names for the team, right? Barca, Barcelona.
Exactly. And this is all about linguistic capture and search ranking. Semantic search systems, they treat these linguistic variants, like searching Barca versus the full Barcelona, as completely different retrieval paths. Smart content creators, they know this. So they use things like mirrored titles, bilingual captions, maybe full translations, just to capture multiple ranking pipelines at the same time. It ensures their multilingual audience gets routed efficiently without getting penalized for duplicate content.
Sounds like the systems are kind of rewarding creators who really understand how to game the linguistic model. Okay, let's dive into memory. Nostalgia. Former NFL MVP Shaun Alexander. The announcement that he and his wife are expecting child number 14. This news was linked directly to his old football highlights.
Yeah, this is a perfect example of legacy content revitalization. AI remasters using things like frame interpolation and super resolution, basically making that old footage look incredibly smooth and sharp. They ensure those, say, 2005 era highlights really pop next to modern 4K clips in your feed. So this family news triggers what the sources call nostalgia clustering. It links the current event to these curated retro reels for maximum engagement.
Our sources flagged something interesting here, though. They called it resolution anchoring bias. That sounds subtle, but potentially a huge influence on how we perceive sports history.
Oh, it absolutely is. Think about it. If you take low-res, grainy footage from 20 years ago and use AI to make it look crisp, high definition, it psychologically biases you, the viewer. You perceive the athletic movement in that newly clarified footage as maybe objectively superior to grainy footage of a player today, even if the underlying performance was similar. So it kind of artificially enhances the perceived greatness of past athletes. It could genuinely bias GOAT debates simply because the old footage looks clearer than it actually was, or clearer than our memory of it.
Wow. The tool meant to clarify history might actually be skewing it towards the past.
Okay, let's shift gears slightly. Breaking political news. Like the report about Defense Secretary Pete Hegseth abruptly summoning generals and admirals. How does AI handle that kind of controversy velocity?
Well, social platforms don't just measure clicks anymore. They actively model controversy. They use metrics like comment velocity, negative sentiment clustering, stuff like that to escalate the story rapidly across feeds, get it maximum attention. However, the systems also deploy some pretty sophisticated countermeasures at the same time.
Countermeasures. What kind of countermeasures are we talking about, especially when a breaking story involves complex government actions? OSINT. Open source intelligence analysts. They're using tools like entity resolution and media forensics to try and map timeline gaps across official statements, news reports, social media. For the listener, OSINT is just collecting and analyzing publicly available data, but it's done at massive scale by AI tools now. The goal is to quickly provide some kind of verified timeline, try to reduce the speed and intensity of the rumor cascade, even while the platform itself is maximizing attention on the initial, maybe controversial story.
So it's a dual system, one pushing for maximum attention, the other trying for rapid fact verification. And finally, in this segment, a quick look at global politics and compression. The sentencing of former French President Nicolas Sarkozy.
Right. When a big, high-profile legal verdict like that drops, you instantly see these rapid explainer cards pushed out by multilingual summarizers. They're incredibly convenient for getting the news fast, but our sources really emphasize that the inherent compression bias in these summaries flattens crucial nuance. If the summary is too short, too compressed, it often loses the essential context, the judicial reasoning, mitigation factors. The best practice they recommend is still pairing those quick AI digests with the court's actual primary documents if you really want to preserve that essential context.
Okay. We've seen AI managing sentiment, memory, political controversy. For our final segment, let's shift to how these sophisticated models manage, well, the physical world, infrastructure, risk, commerce, the engine running the global economy.
Yeah, this is the really operational side. Let's start with something like weather. Tropical storm Humberto is in the sources. We're relying on AI for increasingly refined forecasts now, especially in those short time windows.
Right, we all know the classical weather models, the ensembles that give us the broad track, the spaghetti plots. How does this ML nowcasting improve on that?
So those classical ensembles give us the macro view, right? The track spread over days. ML nowcasting, it specifically refines short window intensity and things like rip current probabilities. It's less about where the storm will be in 3 days and more about what's happening right now or in the next hour at the coast, sudden danger zones. The key advice from the sources for listeners is trust the consensus blends, look at the cone's historical error rate, rather than getting fixated on just one single, maybe dramatic-looking spaghetti line you see screenshotted online.
That's practical advice, potentially life-saving. Okay, shifting to commerce. What happens when a vital logistics network breaks down, like the example of the Canada Post national strike?
Yeah.
How do businesses keep things moving?
Yeah, that's a real-time stress test for operational AI. When those sudden, massive service delays hit, retailers instantly pivot to what are called multi-carrier optimizers. These systems use reinforcement learning to dynamically rebalance cost versus delivery delay. They look across every available carrier in real time and reroute packages.
Okay, so that manages the package routing. But what about the customer experience during all that chaos, people waiting for their stuff?
This is where large language models, LLMs, become really vital operational tools. They generate proactive, highly personalized, estimated time of arrival, ETA messages. These messages get routed directly to the customer based on which carrier the optimizer just shifted their package to. This automated, constant communication, it serves a huge function. It dramatically deloads customer support centers during these massive disruptions. Because the customer is automatically kept in the loop, it stops the delay turning into an angry phone call.
So AI is basically creating a more resilient supply chain while also managing the emotional labor of customer communication. That's clever. We see similar efficiency drives in retail too, right? Like the announcement of Starbucks closing stores in the US and Canada.
Absolutely. Those closure decisions, they aren't arbitrary. They rely heavily on site selection models and foot traffic inference models. These flag stores suffering from cannibalization, where a newer, maybe better performing store nearby is stealing its customers, or stores that are just generally underperforming compared to their neighbors.
And once a store closes, what does the system do with those displaced customers? Does it just lose them?
No way. Their loyalty apps immediately kick in, running geo experiments. If you used to visit that closed location, the system uses targeted offers, experiments to nudge you towards other nearby, hopefully high-performing cafes. Or even better for Starbucks' efficiency, towards BOPIS partners, buy online, pick up in store. It maintains the revenue stream without losing the customer completely.
Huh. So even the journey of my morning coffee is being managed by some predictive model focused on optimizing revenue. Okay, finally, let's just quickly touch on targeted commerce in gaming. Specifically, the launch news for the PS5 title, Ghost of Yōtei.
Right. Game storefronts, they use really sophisticated lookalike clustering based on user wish lists. They don't just target the obvious core players for an action game, they specifically target adjacent player groups. Often people classified by the system as, say, cozy action players, people who might not normally buy a big action title, but maybe will if the presentation, the vibe is exactly right.
And how do they make sure the presentation is right?
Diffusion tools. These are the AI creative tools used to generate huge amounts of atmospheric trailer footage, B-roll, really quickly and cheaply. This lets even small development teams rapidly A/B test different creative approaches against different audience segments until the recommendation loop really locks in and gets maximum traction for that crucial launch window.
Wow, okay. We have covered so much ground. Everything from how a quarterback's highlight reel might be selectively boosted to influence betting markets, to how LLMs generate proactive emails during an international postal strike, and even how AI uses this sentiment drift to turn a niche event into mainstream news seemingly overnight. So what does this all mean? What's the big takeaway?
I think it means we really need to adjust how we think about information flow. These models, they're not just sorting data passively. They're actively shaping outcomes. They're steering retail traffic. They're refining weather risks minute by minute. And they are often using emotional metrics, determining what even qualifies as breaking news content for you personally. The system isn't just showing you the world, it's optimizing your attention towards some kind of profitable or measurable endpoint.
We've seen how AI models controversy, models sentiment, models popularity before boosting content into your feeds. So the provocative thought for you listening is this. If content is being escalated, being promoted, specifically because these sentiment models predict it will be successful, predict it will grab attention, how do you distinguish between genuine bottom-up public interest and really sophisticated algorithmic nudging when you're scrolling through your own feed? That's the real challenge, isn't it? Separating the signal from the model's intent the next time a headline just pops up. Thank you for joining us for the deep dive.